have to make the solution of the loading for impulse loading and the periodic loading, and after that we have to just only put force the force component in the place of equation of motion, and the rest is the same. The rest process is the same. So let's today start with a new concept here. Okay. So as of now, we were talking more about single degree of freedom system, isn't it? So single degree of freedom system means there is only a singular freedom is in the system. Only in one direction the system, or one independent direction or axis, that system can move. But now in a physical reality, there will not only be a system where independent motion will be in a single direction, right? It will be in a multiple direction, two or more than two. So let's get into that depth of knowledge. So, in the previous chapters, we have seen that the structures are modeled as single degree of freedom. But the dynamic response of a structure cannot be described adequately by single degree of freedom model, obviously. So, we always try to understand anything, whether it is in a science or an engineer prospect or a maths, whatever. We always try to understand anything in a nutshell first, in a basic, or a what it can affect in a singular form. Well, in order to know a universe, or if you want to know the basic of a life, then you need to get into the cell, the very singular thing. Or in any way, if you want to know about a universe, you need to know a very singular thing first, a very basic, and what is the source. So always, in order to understand a very huge thing, you need to know the singular form of that particular thing. So here, that is why all the description and all the model are initially created for a very basic things only. So we have also studied that same with that same methodology. So usually the response includes time variation of the displacement shape as well as its amplitude. So what we have understood from there, we have seen the variation of displacement shape and as well as the amplitude. Well, the amplitude was defining whether it is a displacement, whether it is an acceleration, whether it is a velocity with respect to the time plotting. So such behavior can be described only in terms of more than one independent displacement coordinate. Okay, obviously, because we were only judging a displacement parameter only by one coordinate, isn't it? But the motion must be, just a minute. Okay. But the motion must be represented by more than one degree of freedom. Well, you have already come so far in your structural analysis class in the place where we have discussed about the kinematic determinacy. Remember, where we have also studied about the degree of freedom. So, what was the degree of freedom of a system? Degree of freedom of a system was in which independent direction that system or that particular body can move. That was that system's independent moving direction, or the degree of freedom. How many degree, up to how many degree that system has a freedom to move. That is the only basic definition of that. So in a dynamic system, there is also a component or a parameter of a degree of freedom as well. So the system which requires two independent coordinates. So now if you are if you are looking at a system which has a two independent degree of freedom, it will definitely have a two independent coordinate to describe that motion, obviously. So we were only discussing about a coordinate where it was only a single form. So to describe the motion completely is called two degrees of freedom system. In general, a system requires n number of independent coordinates to describe its motion called multi-degree of freedom system. A two degree of freedom is therefore a special case of multi-degree of freedom system. Generally, the number of degrees of freedom is equal to the number of discrete masses of the system. So, here there is also another easy way that you can perform how to calculate the degree of freedom of a particular system is you will look at how many lumped masses are situated in the system. Firstly follow at how many lumped masses are in that system. So that individual lumped mass will have their own individual inertial property, isn't it? So that inertial property will definitely try to create a motion of their individual. So their individual will obviously have their own degree of freedom, will I mean independency of moving independently to a certain direction. So, discrete masses of system, but this is not always true. So the system will having two equations of motion. The lowest frequency of vibration is called fundamental frequency, and the corresponding displacement shape of vibration is called fundamental or first mode of vibration. Well, this is very much important because in a multiple in the scenario of the system where there will be a multiple independent motion or directional motion, there in that case there will be a certain amount of natural frequency as well. So as long as the masses the number of masses are lumped masses are in the system, there will be a natural frequency corresponding to that masses as well. So there you will have a different kind of a frequency. Well, just a minute. So this building, each and every floor will have their own masses. So basically, when a ground motion will come in a certain direction, say a ground motion is coming in this way. So a ground motion is coming in this way. Okay. So what happens in generally? Try to predict, I mean not predict, try to just imagine what will happen. What, it will depend, say each and which part of this structure will tend to move much more. So there is an we can also just establish that building model in this way also. Let me show you kind of a system, isn't, can't we just do that? So there must be some spring in this. So that particular boxes is representing a lumped mass. So lumped mass of what? Lumped mass of this each and individual. This is the floor lumped mass. This is a, sorry, this is a roof lumped mass. This is a, say this is a first floor lumped mass. This is second floor lumped mass. Mean this is third floor lumped mass. And these lines are representing the columns of the building. And this is fixed in a base or in a ground. So can't we just model this thing, this building in this manner as well? So now see, when a ground motion is coming to that, well, each and individual have its own different masses. So due to that inertial effect of the masses, we know that when there is a mass, there will be an inertia. So when a force is coming to that body, well, this base is attached with the ground, right? This is a fixed base. So this part will not tend to move. But that top part in the roof part that is not connected or attached with anything, isn't it? So the basic displacement will happen in that part. There will be a displacement in ground also, because a ground motion is occurring. So there if say a building's reference point is this was the actual point of building, but due to ground motion it has moved in such way. It has displaced in this way. Okay, so there will be a ground motion as well, but due to its fixedness in the ground, the most susceptible part of motion will be faced by the roof of the building, isn't it? So the inertial effect to each and every masses will also be different. मतलब कि इनर्शिया इफेक्ट क्या होता है? जब तुम बस में खड़े रहते हो, बस जब बहुत जोर से चल रहा होता है और बहुत जोर से एक ब्रेक लगाता है, तो तब तुम लोग क्या करते हो? वो सामने की ओर ऐसे झुक जाते हो, isn't it? You uh, tend to incline in a forward way due to the inertial effect. So ये भी तो एक रेस्टिंग सिचुएशन में बिल्डिंग रहता है ना. तो जब ग्राउंड मोशन आएगा, दैट ड्यू टू दैट ग्राउंड मोशन इफेक्ट, वो भी अपने असली जगह पे रहने की कोशिश करेगा. वो अपनी जगह पे रहने की कोशिश करने के वजह से वो क्या, अपने जगह पे, ये दैट वाज इट्स ओरिजिनल प्लेस, राइट? That was its original place. So this will try to keep on its original place only. So ड्यू टू द फिक्सेशन ऑफ द ग्राउंड ये उतना ज्यादा कुछ नहीं कर पाता है, बट द टॉप वन विल बी मच मोर इफेक्टेड, और द टॉप पार्ट विल डेफिनेटली ट्राई टू कीप इट्स पोजीशन टू इट्स प्रीवियस पार्ट. तो हम लोग क्या करते हैं, जो बस में जो ब्रेक को ऐसे जोर से दबाने से क्या होता है, हम लोग पैर से तो आगे चले जाते ही है कभी कभी, ड्यू टू आवर स्टेबिलिटी कंडीशन, पर हमारा जो सामने बॉडी का जो फ्रंट वाला पोर्शन होता है, आवर हेड पार्ट, दैट टेंड टू गो मोर देन आवर लेग, क्योंकि दैट पार्ट इज नॉट अटैच्ड विद द बस. तो इसी वजह से दैट टॉप मास will tend to have a much more deflection. Next, the second, the third, the second. Just let me. So that will tend to move in this way, है ना? हमारा पूरा जो हर एक मास तो एक ही डायरेक्शन में नहीं मूव कर सकता. So that will try to move in a certain direction. So a certain deflection will occur to each and every masses from its original position. Okay, so that due to that, for each and every mass, what we know for the case of frequency, what is the formula of frequency? It is root over k by m. Remember? So there is a mass component. So for each and individual mass component, there must be each and individual natural frequency. मतलब कि अपने natural system का हम लोग अभी तक के natural frequency जो एक ही निकाल रहे थे, because we were dealing with the single degree of freedom system. But in the case of multi-degree of freedom system, we have to cope with a different, with a numerous number of natural frequencies of the system. So among those natural frequency, which would be more, which would be maximum or which would be minimum, we have to focus on that only. क्योंकि ज्यादा मैक्सिमम नेचुरल फ्रीक्वेंसी जिस मोड में होगा, वो ही हमारा ज्यादा वो सिनारियो स्ट्रक्चर में क्रिएट कर सकता है, और अगर नेगेटिव में रहा तो वो भी ज्यादा हमको मोड आई मीन इफेक्ट कर सकता है. सो दैट इज वाई वी ऑफन कंसीडर दोज ओनली, बट अदरवाइज वी हैव टू check over the total or the number of natural frequencies as well. So the technique of evaluating the natural frequency, क्योंकि देखो यहाँ पे हम लोग एक एक मास को अलग से नहीं कैलकुलेट करते हैं. See, these mass are connected to each and every masses along with it, isn't it? तो ये मास हमारे एक मास से जुड़ा हुआ है. सो the inertial property will definitely get attached to another mass as well. So similarly, that mass's inertial property and the stiffness coefficients are also attached with the another masses as well. So these are the things which we have to consider also, because the mass will not only move with its inertial property by its own, because it is also attached with the other masses, lumped masses as well. Okay, so that is why this connection this connection of the masses with one to another, that connection can also be represented by the numerical representation or mathematical form. तब आएगा हमारे केस में मैट्रिक्स सॉल्यूशन. Okay, so I will come into that. Let me just describe it. So um, So when the both masses vibrates at same frequency and in a phase, a definite relationship exists between the amplitudes of two coordinates and the displacement configuration, which is called principal mode of vibration. So if in the principal mode of vibration the amplitude of one of the masses is unity, it is known as normal mode of vibration. So numerical results can be easily obtained for 2 degree of freedom system, and they provided a simple introduction to behavior of system of higher degree of freedom. So यहाँ पे देखो, just look into that. There are so many kind of other definitions like fundamental frequency, fundamental first mode of vibration, principal mode of vibration. So see, again look into that. We are only focusing on a specific kind of a parameter. We are not just having a singular parameter. We are just specifying one of that. So we will be having a multiple number in the case of multi-degree of freedom system as well. So 2 degree of freedom system will definitely give you glimpse of a glimpse of higher degree of freedom systems behavior. Show you this part from this content only. See, in the case of multi-degree of freedom system, as the name suggests, is one that requires two or more independent coordinates to describe its motion. This is a very easy and very appropriate term to define the multi-degree of freedom system motion. So it is that one requires two or more independent coordinates. So here the coordinate term is very much important. So in order to describe its motion, so the coordinates normally used to describe the motion of a structural system may be related to each other via some constraint, which could either be simple kinematic relation between various coordinates, or they could arise from consideration of equilibrium of forces. So now let us come, the number of generalized or independent coordinates is given by the difference between the total coordinates describing. Okay, so we have already done a Cartesian coordinate system in our class, say 11 or 12 maybe. So we have already done. So just look into this diagram. This is a diagram of a double pendulum. So what is double pendulum? So double pendulum depicts a scenario where there is two masses situated along with it, and these masses are connected with two rods. Okay, and it is that pendulum is connected to a fixed base. Okay, connected to a fixed base, and it is having its own leveling of C. That pendulum is connected with a length of rod L1 with a mass M1, and this pendulum is connected with a L2 rod with having a M2 mass. So this is a basic materialistic property of a pendulum. Now the way how it will move, that we will try to analyze. So how we can analyze? We can put it into a Cartesian coordinate system. See, here are first pendulums length or this chain or attached or attaching property. this is making a angle of theta 1 from x coordinate. Okay, this is creating a theta 1 angle from x coordinate. And the next part, the next pendulum, the next mass is creating theta 2 from its previous mass's location. From its previous mass location, it is creating theta 2 of angle. So now that mass's coordinate is x1, x1, y1. What is x1, y1? This is our x1, this is our x1, and this is our y1. This is y1, this is x1. Similarly, for this, okay, so these are our coordinates. So now how we can simplify that further? So coordinate system, the position of two masses m1 and m2 are described by two pairs of Cartesian coordinates, x1, y1 and x2, y2 respectively. These four coordinates are x1, y1, x2, y2. Okay. So however, are related to each other through two constraint relations. So now we can create or make a two constraint relation, possible constraint relation. So what are those? See, for this mass, this is a inclined part, right? ये तो हमारा inclined part है और ये inclined part हमको कैसा कैसा लग रहा है? Isn't it looking like a right angle triangle? तो राइट एंगल ट्रायंगल में पिथागोरस का जो फॉर्मूला था वो कैसा था? दैट वाज आवर हाइट स्क्वायर और लेंथ स्क्वायर प्लस base square is equal to the hypotenuse square. Remember in the Pythagoras formula? So now see, in or we are so this is our hypotenuse L1. So L1 whole square is equal to our base whole square plus our length whole square. So that we can write an equation in this form. अब ये सेकंड के लिए हम लोग कैसे रिप्रेजेंट करेंगे? We can represent that as, see, this is our x1, right? And our x2 is this. This is our x2. So now x2 minus x1 whole square plus y2 minus y1. So x2 minus x1 कौन सा है? ये है हमारा ये वाला. ये है हमारा, this length is our x2 minus x1. So which one is x1? This one. And x2 is our this one. So this remaining part is this. Similarly, yes, similarly for y2 minus y1. So which one is y1? Y1 is this part. Okay, and y2 is this part. So y2 minus y1 will give me the rest of the length. So this part is making that hypotenuse of L2 whole square. So this possible equation we can form for right now. So thus the number of degrees of freedom or generalized coordinates of structural system is 4 minus 2. Well, see, these are where our four coordinates x1, y1, x2, y2. So now after simplification we got that it is our 2. Our generalized degree of freedom is 2. The angles theta1 and theta2 can be taken as two independent generalized coordinates to describe the motion of the masses. In certain system, it is possible to eliminate dependent variable by using constraint relation. Remember, हम लोग degree of freedom और या फिर statical indeterminacy में क्या करते थे? If we would have required to make a certain system for say a system is giving me a first degree of statical indeterminacy system, say, तो उसको हम लोग कोई भी एक पैरामीटर ऐड करके उसको हम लोग स्टैटिकल डिटरमिनेंसी बना सकते थे. We were able to make such things, but in that case, in certain system it is possible to eliminate that dependent. तो हम लोग ऐड करके या फिर एलिमिनेट करके उसको बना रहे थे. Okay, so by using constraint relation and derive a set of generalized coordinates. and these are said to be holonomic constraints. So these are some definitions which is given here. So now here let us come back to this. So this were our same things. Sorry. तो हम लोग क्या पेंडुलम में वो that we were looking at the pendulum scenario. Now see that pendulum can be represented also as in the 2 degree of freedom system in such a mass spring dashpot system. So here dashpot is not present, mass spring system. See here that mass can be represented in that lumped mass, and that connecting rod can be represented as the spring column, which will have a certain amount of stiffness. And in C, the degree of freedom, what we have considered here, theta, theta of the masses. Now in that case, that deflection was in this way, isn't it? But see, for this system, the deflection is in this way. So there is also a 2 degree of freedom system representation. We can see that. So sorry, here building is defined as a structure in which no rotation of a horizontal member at floor level. Since or mean ये हमारा जो दिस वॉज आवर बिल्डिंग राइट, तो ये फ्लोर लेवल में कोई यहाँ पे ओके कोई यहाँ पे ऐसा कोई रोटेशन नहीं फॉर्म होता है ऑन दिस इंडिविजुअल फ्लोर्स. You cannot observe any kind of rotation. Then only the shear will occur at these individual floors, isn't it? So the condition will be the floor will not have any kind of rotational motion. Then only a floor can possibly experience the shear effect. So the total mass of structure is concentrated at, these are the condition, the idealization or the assumption of building. जैसे कि हम लोग assumption पढ़ते हैं, उसका मतलब क्या होता है? That some boundary conditions or some presumption we have to make it in our mind that after that, मतलब कोई भी एक्सपेरिमेंट करने के बाद वी आर कंसिडरिंग दीज कंडीशंस. सो इफ समवन आस्क आफ्टर दैट कंप्लीशन ऑफ एक्सपेरिमेंट, दैट पर्सन वुड not be asking me that why you have not considered that or this, because I have given the assumption previously. Okay, so now the total mass of a structure is concentrated at the floor level instead of distributed mass. This assumption reduces the infinite number of degrees of freedom as it has lumped mass at floor levels. Okay, so we will here the total mass of structure is concentrated only at floor level. That we only have to presume in that manner. मतलब कि हम लोग distributed mass we will not consider it as a distributed mass. We only just assume that to be lumped mass. अगर हम लोग distributed masses consider कर लेंगे, so what will happen that each and individual distributed mass will have its own independent motion, right? So there will be a numerous amount of multiple degree of freedom system. So that is why we will consider those individual floors as to be the lumped mass. So the horizontal members on floors are infinitely rigid as compared to columns. Obviously, that horizontal members mean these members we will consider as a very rigid part, and that column we will consider as to be very flexible part. ये rigid होगा तभी ना ये पूरा rigid location से और एक location में move करेगा. If what happen if this is not rigid, what will happen? Then हमारा फ्लोर जो है, if that would be flexible part, that would be a flexible part. What will happen? That roof will tend to stretch from one location to another location from its original part, right? But we will consider this as to be rigid part, and the column that we will consider to be the flexible part, because that column will tend to stretch, okay, due to its flexibility. So that assumption you can see here. So the next is the deformation of structures is not affected by the axial force in the columns. Stiffness due to columns and inertia due to slabs are considered. No joint rotation in structure. Loads act horizontally so that slabs move parallel to each other. Okay, so ये load हमारा जो है ये horizontally act करेगा, that all the floors and roof will tend to move parallelly to each other. Okay. So in reality, the mass is distributed throughout the building, but here we will idealize it as concentrated, or the mass is lumped at the floor levels. Therefore, two-story frame with lumped mass at each floor level has 2 degrees of freedom. The shear frame or shear building idealization, although unrealistic, is convenient for understanding or illustrating how the equation of motion for multi-degree of freedom system are developed. See, here the shear building idealization, हम लोग ये structural analysis में पढ़े थे. We have not studied this part only. So this is the equivalent system we can also model. How? See, this frame, as you can see, there is the horizontal members are the masses and the vertical things are the spring constant representation, means these are the columns, and this column will have a certain amount of flexibility, so that is also given ei2 and ei1, and its length is also provided. So here in masses EI, the flexural rigidity is not given because this is infinitely rigid, we have already considered. So now the displacement is in this direction only. So now see, we can model the equivalent system similar to that. So that here you can see the two mass which is connected to each other with K2 spring, just like this. M2 and M1 is connected to this K2 column, and that with that K1 spring constant presumption column, this is connected to a fixed space similar to that. So the displacement is in this direction. So the displacement was in this scenario, this direction, it is in this direction, but it will have a 2 degree of freedom system. Okay, so this is a shear building idealization. So up to this, do you have any problem until now? Anyone? Anyone, please ask. Okay, so I hope not. So I will continue the next part of this lecture in the next class. Okay. So please go through this theory part.